And hi again to video 4, sources of greenhouse gases. Now before we start, I'll just say that I'm recording this on the Sunshine Coast in Queensland, Australia, and the average spring temperature is supposed to be about 28 degrees, but we're expecting about 37 today, so wish me luck. Anyway, here goes. In this video we'll discuss the natural and man-made sources of the greenhouse gases we got to know in the last video. Now, the first thing you've got to realise is that the term greenhouse gas is not a dirty word. Without them, during the day we would bake at hundreds of degrees Celsius and during the night freeze by corresponding amount. So they are absolutely essential to life. Take the climate around the equator, where there is a high concentration of water vapour due to the oceans being warm year-round at around 30 to 32 degrees Celsius. The daytime temps are usually 30 to 35 degrees Celsius, and the nights may be dipped to only around 25. The air is heavy and muggy. It's the high concentration of steam that also largely regulates the temperature as well. You are not going to get a humid day in the mid-40s, for instance, on the equator. Then take the outback of Australia for contrast. Very high and scorching hot during the day, quite often 45 degrees plus, but at night bitterly cold, due again to the air being so dry and very little water vapour to trap the day's heat. What makes life on Earth livable for all its myriad forms of life is the relative balance of the greenhouse gases in the various climatic zones of the planet. As you already know, water vapour, steam, is the most important greenhouse gas produced by heating water, whether that comes from the oceans, seas, lakes, Everglades, rivers, or through industry, water boilers, power stations and the like. Enter CO2. As mentioned before, water vapour is a slave to CO2 and methane. As the concentration of CO2 in the atmosphere keeps relentlessly going up and up and up, more water molecules in close proximity to the heated, energized CO2 molecules warm as well, the radiator effect. Another path is that the atmosphere is overly heated by CO2 molecules absorbing the sun's infrared radiation, and this warms the oceans and other waterway surface, thus releasing more warm steam into the air. Again, volcanoes on land and submarine volcanic vents dotted around the fault lines of continental plates also produce a significant amount of CO2. If you look at the Keeling curve of CO2 over the decades, you'll see a steady and accelerating increase in the amount of atmospheric CO2 over at least the last 50 years. You may be wondering why the curve is serrated or jagged at exactly one serration per year. That's due to the collective breathing or respiration of all the plants in the northern hemisphere. There's a lot more flora in the northern hemisphere than the south, even despite the Amazon rainforest. There's more carbon dioxide in the air in the winter as the plants are not growing fast and therefore taking in less CO2, so there's more in the air. Conversely, there's a dip in atmospheric CO2 during the northern summer as the plants and vast forests are breathing in lots of CO2 for growth. Brief recap on video 2, the carbon cycle. Carbon dioxide is naturally released from the respiration of plants and animals, as well as decomposing plants and animals, and the waste products of animals, their manure and flatulence. Also from volcanic outgassing on land and under the oceans, and weathering of sedimentary rock. Methane is naturally produced by the anaerobic, without oxygen, breakdown of animal and vegetation waste. It is also produced by rice growing and the flatulence of cattle. Cattle flatulence is a good transition step to the human causes of the greenhouse gases. Human causes. Even though water vapour is the main greenhouse gas, being a slave to the other ones means it can be excluded from this list. Number 1 for carbon dioxide is electric power generation from coal, oil and diesel. You may hear about clean coal being touted as an environmentally friendly coal for power stations. Unless the carbon is stored or sequestered in the chimney, it is still a highly concentrated hydrocarbon, and thus will produce mainly CO2 when burnt. Actually, lower grade anthracite or bituminous coal may actually be better due to their additional sulfuric compounds causing a dipping in the sun's intensity, but at a huge cost: acid rain, acidification of the oceans, to name a couple. Commercial and domestic refrigeration and air conditioning produces a lot of CO2 from electricity consumption, and lately the emergence of Bitcoin as an alternative decentralized currency is putting much more strain on your domestic computer. Bitcoin mining is estimated to cause 60 million tons of CO2 per year, equivalent to all the CO2 produced by a country the size of Austria. Huge amount. The transportation industry, including domestic car travel, ships and air. Air travel using aviation fuel is worse than we previously thought, due to the CO2 and nitrous oxide getting injected into the stratosphere or high troposphere. The stratosphere extends from 10 kilometers to 50 kilometers altitude, troposphere below 10 kilometers. The contrails of aircraft cause a little of the sun's rays to get reflected back into space, but most of the energy will get absorbed by the emitted CO2 and nitrous oxide from the jet engines and stay in our atmosphere for thousands of years. Cement production causes vast amounts of CO2, mining and all other industrial processes where fossil fuels are burnt. The clearing of huge tracts of virgin forest for urbanization, for farming, increases CO2 due to the burning of vegetation. This also removes trees that are made to natural carbon sink. As the trees grow, it stores atmospheric carbon in its trunk, leaves and roots. Often the cleared land is used to grow cattle cattle feed, which, as you already know, produces vast amounts of CO2 and methane. Since 1978, over 750,000 square kilometers, or over 1/5, of the Amazonian rainforest has been erased or burnt, with no end in sight. These rainforests, along with the massive boreal forest of the northern hemisphere, happen to be the lungs of the world. Then once the cleared land creates its own drier microclimate, all the forest adjacent to that clearing suffers or dies as well, very much like a cancer spreading. Human sources of methane are from rice paddies, cattle flatulence, biomass burning, coal mining, methane gas production and fracking, and the fugitive or escape emissions from it. An emerging and increasing source of CO2 and methane is caused by the rapid melting to substantial depths of the frozen soil called permafrost in the high latitudes of Siberia and Canada, the tundra. As the soil warms down to 2 meters in depth, or at least 2 meters in depth, vegetation and animal remains that have stayed frozen and intact for many thousands of years are now thawing, and as they thaw, they are releasing increasing amounts of CO2 and methane into the air. Total potential CO2 and methane release from the permafrost could well be over 2,000 gigatons. Likewise, on the seabed of the shallow seas of the Siberian coast are thousands of gigatons of frozen methane hydrates that are already beginning to thaw and will continue to thaw as the effects of global warming take hold on the planet. In the next video, video 5, we will take a look at the world's ancient prehistoric climate leading to the Holocene and to when human beings began affecting the Earth's biological and climatic systems, which logically should now be called, and are going to be called, the Anthropocene. See you there. Whew, I made it. Now, it's getting really hot. Okay, see you. Bye.